Okay, next let's discuss about general regions. Let's consider region which is given by following formula. This one is called general spherical wedge. In this case, you can see that theta is varying with from alpha to beta and phi is from C to D, but rho is between the graph of two functions g1 theta phi and g2 theta phi. Okay, in this case, our triple integral in rectangular coordinate can be calculated by shifting to spherical coordinates, and x, y, z are changed with their spherical values, multiplied the value of the function to Jacobian and the integral. But limits for theta and phi is clear, and rho just will be between g1 and g2. It looks like type 1 region of integration of triple integrals. Let me demonstrate this formula in the solution of the following problem. Use the spherical coordinates to find the volume of the solid G bounded above by the sphere of the radius 4 and below by the cone given by this equation z under root x squared plus y squared. What we do, first we try to find the form of this sphere and cone in the spherical coordinates. For this purpose, I change x, y, z by their spherical coordinates, and I will get that rho square equals to 16, which means rho equals to 4. So that means rho is changing from 0 to 4 because when point in the falling to the origin, rho will be 0. When point falling on the surface, rho will be 4. So rho will be changing from 0 to 4. Next, we calculate the cone to find the relation for phi. Z is rho cosine phi, and x squared plus y squared is rho squared sine squared. We take the root and we solve the equation. We cancel by rho, assuming that rho positive. Then we get tangent phi is 1. So phi is pi over 4. So here what we can say, phi is measuring changing from 0 to pi over 4, because when point falling to the z-axis positive direction, phi is 0. When the point falling to the cone, phi is pi over 4. So because of this, we understand that phi will be between 0 and pi over 4. And to do the projection of this intersection line to xy, we can solve these two equations together, which gives x squared plus y squared equals to root of 8. This is the circle in the xy plane, which is the projection of the intersection of these two surfaces. Next, all calculations I collected here again. So from here we obtain rho from 0 to 4, phi from 0 to pi over 4. Then volume of the integral can be calculated as, of course, it is the formula for volume. First I write the value for theta, which is 0 to pi, and after the value for phi, 0 to pi over 4, and rho from 0 to 4. Then I change the dv with the Jacobian times d rho, d theta, d phi, and d theta. So we have to calculate this triple integral, and limits are found. Okay, here let me explain this integral calculation. Just we integrate by rho first, then it will be rho 3 by 3 from 0 to 4. I substitute the values, I got 64 by 3 sine phi. Then I integrate by phi, it will be, result will be negative cosine phi from 0 to pi over 4. So it means you substitute values will be 1 minus root of 2 by 2. Integrate by theta, then we get the result. So here cosine pi over 4, cosine 0 is 1 minus root of 2 by 2. And this one, the result in the next integral.